Hello. Sorry. So I'm recording myself explaining the continuance of the example. We were doing mesh analysis for analyzing the relationship between the output and input of the figure of this diagram is shown in figure 2.14, page 48 and 49 of the book. I'm just going to remind myself. So this was the figure, and once we had the relationship done by doing the node analysis, this time we are looking at the mesh analysis. That means that we are assuming that I1 is flowing through the first loop on the left side, and then I2 is flowing through the second loop here. So we got to this stage that we had equation 31. So this is, let me use autofocus. Okay, so this is equation 31, which we have the V on the left side, and then we have the rest of things on the right side. We were happy with that, but we need to replace some of the variables on the right side to have the relationship in a way that we have V, and then the other side we have the voltage across the capacitor. So it is VC, our output, on the right side, or some order of its derivative. Now, then we continued to the point that we got to I1. Now, the next stage would be to substitute I1, and you can see here we have only VC on the right side, and we are happy with that. It's second derivative and first derivative of VC, voltage across the capacitor, and then on the left side we have I1. So now we are going to replace or substitute I1 with this value, and then we take it from there. If you're confused what I'm talking about, you can go and check my previous video, and hopefully then it will be a little bit more clear what exactly I'm talking here. Okay, so I'm just going to write it again. Let me do auto, maybe a little bit more light. That looks better. I'm very happy with this virtual presenter. Okay, so we have I1 equal to R2 C2 C1 second derivative of VC in time, and I'm practicing my handwriting. Hopefully it's a little bit better as I go. And then I have C1 plus C2 in first derivative of C. Now I'm going to substitute I1 in my equation 31. I'm going to write down again my equation 31. I keep the names and numbers same as book, just in case if someone wants to look at the book or ebook, so they are consistent. Now, equation 31 is V is equal to I1 R1 plus 1 over C1 integration of I1 over T minus, just keep in mind that this is also C1. There is a mistake in book, just be careful of that. Now I have the C2, and then now I'm going to replace replace this one here and this one here. So for replacing the I1, all I need to do is to have a differentiation of that equation on the top. So by getting the differentiation of both sides of this, I can get the integration of I1 dt. I don't know, I don't remember if I explained that part in previous video or not, but I think I'm going to actually do it one more time, just in case if I haven't done that in previous video. So for the first one, for the first part, I'm happy. I have the I1 directly. I'm just going to substitute that part. For the integration, I need to have that integration, not differentiation. Sorry for my mistake. So I'm just going to apply integration for both sides of this equation. So I'm just going to do integration here. So I will have integration of I1 dt on the left side, and for the right side I am going to have integration applied on each side of these. For the first part, you can see that I have second derivative over time, so one order will be cancelled with integration and I will have the first derivative. So the constants R2, C2, C1, they stay outside, and that one turns to first derivative of Vc in time. For the second part, the first order derivative will be cancelled out with my integration, and Vc comes out, and I have that C1, C2, so it will be like C1 Vc plus C2 Vc. That is the result of integration of that. They have nothing to do with my cloud. Now I have both of them, so I can substitute them in my equation 31. So again, my equation 31 comes here. So my V will be my I1 multiplied in R1. So R1 is going to multiply in each of those words. So it will become R1, R2, C2, C1, second derivative, plus. Now I can keep it up as that form, or I can just break it down, separate it, and then I multiply my R inside. So let's do it that way. So I will have C1 R1 derivative plus, does it show the camera? I continue here, so it will be C2 R1 another derivative. I'm done with my first part of my equation 31. For the second part, I have 1 over C1, and then I have that integration. So 1 over C1 is going to multiply in entire this guy here. Now I have plus sign. I'm happy with that. Now let's multiply that one inside this one. So if I want to multiply 1 over C1 in the first part of this, so you can see that C1 and this C1, they cancel each other. So it will become like R2 C2 derivative of C Vc in time. Now for the second and third part, I have C1 multiplying in them. So that C1 and this C1, they will cancel each other, and then I will have Vc. So I have Vc here, and then for the last part, I have C2, so it will be C2 over C1, and then I will have Vc here. So this will be the result of substituting the integration of I1 inside my equation 31 up to this point. Now I still need this part here. So for that part, I'm going to use the part that was related. Let me refer to the previous section. I explained it, if I'm not mistaken, in my previous video, but I'm going to just mention it one more time anyway. So I have this relationship between the I2 and C2. Let me get the focus fixed here. Alright. So this is the relationship between the I2 and C2 and derivative of VC over T. And that is based on the assumption that we have for the mesh. So if I want to quickly go back to the focus now, if I want to, let me see, how can I do that on the same page here? Oh, probably here. Okay, so I'm just going to quickly this is my circuit. Okay, so this guy here was R1, R2, C1 and C2, and my output is this guy here. Now for the mesh, we are saying here we have on the first loop I have I1 flowing and my second loop is I2. Now what we need here is I2. So for I2, I'm looking at my second loop here. Now I have the voltage across this point right now. I know that my I2 is flowing through my C2. So I can write the relationship between the current flowing through this capacitor and the voltage of this capacitor across this capacitor. So if I want to write that, referring to just basic fundamental equations which were displayed in form of a table in my previous video, and also they are available on the slide. Now I2 will be equal to C2 dVc dt. Now you can write it C2 derivative of voltage at this point over time, and then you know that that is equal to Vc. So that is it. Now for the integration of that, so if I want to do integration of I2 over time, the constant C2 comes out, and then the integration and derivative, they cancel each other. So I will have C2 Vc. Now I'm going to use this, substitute that for my integration of I2. So I have a minus, that minus is coming from here, and then I will have this one here. So I have 1 over C1 multiplied in my C2 Vc. So this one here will be cancelled out with this one here, because they are exactly the same and they're just opposite signs. So I'm just going to put a cross here, a cross here. That means that they cancel each other. For the rest, I'm going to rewrite it and clean it up a little bit. So I have my V on the left side, and then I have my R1, R2, C1, C2, second derivative of Vc over time, and then I kind of want to factor out the first derivative. So what I'm going to do is I'm going to write, okay, what do I have here? It's R1 C1 comes out of that, and then R1 C2 comes out of that when I'm factoring out the first derivative, and then I have R2 C2 coming out of my third one, and then the whole thing is multiplied in first derivative of VC over time, and then I have only one thing left, and that is VC. Now I want to remove the constant that is being multiplied in my second derivative. For doing that, for removing that, I'm going to multiply both sides. I'm going to multiply both sides in this one to cancel these guys from my second derivative. So what I will have is my v, because I am multiplying both sides. So on the left side, I will have r1, v over r1, r2, c1, c2. And on the right side, this guy will be cancelled out with that division. So my second derivative will have no constant being multiplied in it. And then for this part, I'm going to have a very big division. And then also I'm going to have my VC also divided by that. So here I will have R1, R2, C1, and C2. The bottom of this fraction is R1, R2, C1, C2, and on the top, these will stay the same. So I will have R1, C1 plus R1, C2 plus R2, C2. And that is the result of that mesh analysis. This is exactly the same equation that we did with node analysis. So this is the final relationship. Well, my handwriting is not good. If I want to rewrite that again, that would be great. So let's do that, and then I look at it again. Now say R1, R2, C1, C2, and second derivative of VC over T plus dVC dt, and then plus VC, let's take that out, R1, R2, C1, C2, R1, C1, R2, C2. So you can see that I have kind of a combination here. R2, C2 plus R1, C2. Now, on the left side, let me see if I have colors here. I don't see the other colorful stuff. Anyway, so on the left side I have only V and the rest is constant. So this is my input. And on the right side, here is second order of derivative of output. And here is the first derivative of my output multiplied in some constant. These are all constant, so that will be like result of addition and division of some numbers. So this is like first derivative of output. And my third part of this equation, this formula will be my output itself multiplied in some constant. So this is the output. And that will complete the analysis of this example using mesh or Kirchhoff's second law. Now we have example 4. I'm not sure if I should do it in this video. I should probably record another video so you have it separate, because this is like a complement or continuous of previous video. Okay, so go ahead and check other videos. Thank you.